So good morning students, 12th standard physics. So in this class we are going to discuss about illustration 2, somewhat relating Lenz law, then conservation of energy again, it's how it's related with Lenz law, then finally Fleming right hand rule. So first Lenz law, so the induced current, the direction of induced current is always opposite the cause for the responsible for the production. So there is a change in magnetic flux linked with the coil, there should be an induced EMF or induced current produced in the coil. So the induced EMF, then the change in magnetic flux, it's always in opposite direction. So consider a bar magnet. So bar magnet is at rest, then a coil is connected with the galvanometer. So now there is no deflection due to the bar magnets because the bar magnet is at rest. Now as I am going to do one experiment, so the bar magnet is moving towards the coil. So if a bar magnet means it's north pole and south pole, so magnetic dipole, so magnetic line starts from north and at south. So again, so I am moving towards the coil, so there is a change in magnetic flux linked with the coil, there should be an induced current produced in the coil. So that's a direction of induced current, it shows in the galvanometer. So due to the flow of current in the coil, so there should be it acts as a magnetic dipole. So one end is north pole, how it find out? So now the bar magnet, so it's a north pole, it's a south pole, so I am moving towards the bar magnet towards the coil. So there is a induced current produced in the coil. So the bar magnet sends the repulsive force. So repulsive force means, so already we know this is a north pole, but the one end of the coil, it should be a north pole. That should be if it is a reflection, this end is north pole. By knowing the two ends of the coil, that is what is the direction of magnetic field, so we can find the direction of current. How? So just think like that. So direction of current is always opposite to the direction of electron. So the electron flow and current flow is always in opposite in direction. Here the current flow is in this direction. So the magnetic field should be in opposite direction. So the magnetic field means, so the magnetic field line starts from north ended. So the current flow in this direction means, so the magnetic flow in opposite direction. Just think like that. So by knowing the direction of magnetic field, we know the direction of current. And also simply, so the direction of the moving coil, so the direction of the bar magnet moving towards the coil, so the current flow in opposite direction. So the cause and effect is always in opposite, that is the Lenz law. So if it is moving towards means there should be a repulsive force. So it won't oppose, it won't help. That is the bar magnet, we can't move towards the coil at a certain extent. Then, so I am going to remove the magnet. So I am just withdraw the magnet away from the coil. Now again there should be attractive force. So if a bar magnet is moving towards the coil, there should be a repulsive force. That means, so we know the bar magnet, so which end we are showing towards the coil. So if it is north, if it is a repulsive force means this end should be north pole. So the current flows in this direction. Now the bar magnet is away from the coil. So I am withdraw the bar magnet away from the coil. So there should be a attractive force. So the current direction changes. So the polarity of, that is north pole becomes south pole. So the current flow direction. So I am taking away. So the current flows in opposite direction. So current flows in opposite direction. So again the cause and effects is always in opposite direction. So it explains the Lenz law. The next, conservation of energy. How it is related with Lenz law? So what's my conservation of energy? It's a fundamental law. So energy can neither be created nor be destroyed. It can transfer from one form to another form. So here, so there will always a resisting force on a moving magnet. So a bar magnet is moving towards the coil, there should be a repulsive force, that is a resisting force. Again the bar magnet is moving away from the coil, there should be a attractive force, so that's a resisting force. So there will always a resisting force on the moving magnet. So some work should be done to move the magnet towards the coil, so against the resistive force. So I am moving towards the coil against the repulsive force, again I am withdraw the magnet against the attractive force. So some work is done to move the magnet against the resistive force, so that work done. Here the organ is converted to electrical energy. Now we are moving towards the coil, that should be a mechanical energy. So here mechanical energy is converted into electrical energy. So electrical energy means there is a flow of induced current in the coil. So that is sensed through the galvanometer. So the direction of galvanometer, so initially it is at rest, so the bar magnet is at rest, so it shows zero deflection. So I am moving towards the coil, so I am moving towards, the deflection should be in opposite direction because cause and effect are in opposite direction according to Lenz law. So again I am moving away from the coil, so the bar magnet is moving away from the coil, so it's away, so the direction of deflection is also in opposite direction. So there should be a resisting force, that may be a repulsive force as well as attractive force, depend upon we are moving towards the coil or we are moving away from the coil. So here the mechanical energy is converted into electrical energy. Again the electrical energy is converted into Joule heat, that is current carrying conductor. So around the current carrying conductor there should be a magnetic field as well as a current carrying conductor will heat, that is Joule heating effect. Then just think, just assume, so the induced current help the cause responsible for the protection. So there should be a cause, there should be a effect. So which is a cause? So there is a change in magnetic flux produced by the bar magnet. So the induced current, that is the effect. So cause and effect. So the effect helps, that is induced current helps the responsible for the protection. So the induced current flows in the coil. So I am moving towards that bar magnet moving towards the coil. So the induced current helps means it easily goes towards the coil. If it like that, we won't use any energy. So then the magnet starts moving towards the coil without any expense of energy. So this is not possible. This is impossible case. So the assumption is wrong. So how? So I am not using any energy. The magnet directly goes into. So this is not possible. So according to Lenz law. So the Lenz law is a very good example for conservation of energy. So energy transfer from mechanical energy into electrical energy, then electrical energy into and heat energy. Then finally Fleming right hand rule, it's also called generator rule. Then so just stretch the forefinger or index finger. So this is the index finger of our right hand. So stretch the index finger, thumb and middle finger mutually perpendicular to each other. Just see mutually perpendicular means, so thumb, the angle between the thumb and index finger is 90 degree. Again see that index finger and middle finger is 90 degree. Then see this one and this one. So the thumb and middle finger, it's 90 degree. So mutually perpendicular to each other. So the index finger points in the direction of magnetic field, thumb points in the direction of motion of the conductor, the middle finger points in the direction of induced current. So how it apply? So just see the between the bar magnets, so the conductor is placed. I am moving upwards. So I am moving upwards, that is the upward direction is the direction of the conductor. So conductor moving upwards. So that is thumb. Then the index finger points in the direction of magnetic field. Just see, the thumb shows the direction of motion of the conductor. Then the index finger points in the direction of magnetic field. Then the middle finger points in the direction of current. So if we move the conductor in the magnetic field upwards, the direction of current from here to there. So that is the middle finger points in the direction of induced current. So that should be an induced current due to the change in magnetic flux linked with the conductor. So according to electromagnetic induction. So in this class we have discussed Lenz law illustration 2, then how the Lenz law is related with conservation of energy, then finally Fleming right hand rule. So okay students, thank you.